it's looking like everything is set. I'll wait for 5 minutes and then we'll start this session. So let's get started. Welcome everyone to our session on closing the loop in ML systems. Before we get started, I just wanted to discuss my ML journey to FAN. I started my machine learning journey in 2011, and at that time I took what everyone takes right now, Andrew Ng's course. It really excited me for pursuing this field. And in 2012, I joined as a software engineer at a company. And because I was not able to pursue my career in machine learning, I quit that job in 3 months. I went to Triple IT for an unpaid internship. I was thinking like maybe in 8 months, 6 months, I'll learn enough of ML and get a job at these top companies. And I was totally wrong. In 6 months, what I learned was I know nothing. And that's where I opened my eyes and really focused on my foundations. And I became a research assistant there, along with being a research assistant for a few years. I did my master's also and had a research degree with specialization in computer vision and machine learning. Then again, I had no clue where would I get a job or anything. I didn't think too much about the job beforehand, and I didn't prep at all. So it was kind of hazy. But then luckily, I focused on machine learning in these years so much that it was kind of comfortable in all the interviews and all from machine learning point of view. I spent some time on data structures and algorithms so that my weakness doesn't give me a setback, right? So I started my job in 2016. I was an applied scientist at Amazon for almost 6 years. Learned a lot, worked on a lot of practical problems, very challenging problems. Then I moved on to Microsoft as a senior applied scientist. There I was working on visual ads. And then we are at 2024. I'm working full time on this project called the Curious Curator. And that's why you're here for this session. So please visit our website. A bit about Curious Curator. We offer 12-month data science and machine learning course. It's really comprehensive. I don't know if there is any better course out there, right? So what we are offering, please explore the website and see the tentative syllabus of this course and convince yourself if there is nothing better. You can visit our website and look at the course details. So let's look at this application, right? And I wanted to use this application because there are other trivial retraining loops which close the loops. And this example really opens our eyes in a way which some automatic weekly retraining might not. So this simple example is cat dog classification. We have a model and the model takes an input image and it tells us whether it's a cat or a dog. This is a simple application which you have to keep at the back of your mind. Another example you might keep at the back of your mind might be a recommendation system. And when you change something in the model, somewhere in the production system, that change will improve the quality of recommendations, which the users are more likely to engage with the platform, right? So these two examples are kind of useful when we are thinking about closing the loop in ML systems. So before we move there, let's look at open loop thinking, or what I say is classroom thinking, right? So we have our data set, we prep our data, do our feature engineering and so on. And we have a collection of ideas, either it could be models or how we can tune hyperparameters. And we fall into this loop of improving the model, right? And once we are getting a really good model on our validation and test set, we do some offline evaluation on test set and we choose our best option. And that option will go into the product. This is our open loop or classroom thinking. But that's not always the case in real world, right? That's the reason of this talk. It's not that simple. So there's this MLOps life cycle, machine learning operations, and this is a loop where it's a full life cycle in terms of MLOps. But even each step could itself be a cycle. It depends how it is. So first we do exploratory data analysis. So we get our data, we do some exploratory data analysis, we kind of understand our data and some statistics of the data, missing values, how our data behaves, the separation between classes and so on, right? It is just for that we do EDA in product setup so that we understand our data or we have some intuition on how to improve our data. Next is data prep and feature engineering. Because we understand our data, it's easier to remove outliers because we have done our analysis. We can remove duplicates. We can do feature engineering based on our understanding of the domain, right? Then we do model training and tuning. Again, choice of model and how to improve the model with the data we have. Or can we add an auxiliary data and significantly improve the model and so on, right? Then there's this model review and governance. What can happen is the team works on improving the whole system, and every person in the team are handling a small part of the system. So periodically there would be meetings where the model performance is reviewed and the impact of that model on the system or business, and that's the governance part as well. We'll talk about all of these, but I'm just giving a short few sentences. Then we have model inference and serving. How do we expose the model to an application or the user, right? Then we have model monitoring, and then we have automated model retraining. So this loop kind of gives us a good idea of what is an MLOps cycle. And this closing the loop is kind of inspired from there. There are other aspects as well, which we'll talk about much later. But let's look at all these steps first. So the first step in this cycle is exploratory data analysis. Again, I've already talked about it, that we identify the statistical properties of the data. And we really want to understand our data, how the class are separated in the feature space, whether there are missing values or not, some important business metrics on the data which we have. And why do we need to do EDA in practical setup, right? First is understanding our data. Second is, if we understand our data, it's easier to clean the data. It's easier to remove outliers if needed. It's easier to do some kind of label imputation if needed. And most importantly, when we are in a meeting, when we have a job, if we are working on a problem, we kind of should have some idea of our data, right? Because when we are going with a proposal or some model improvement or some idea, right, or some prototype, the performance changes are not always convincing. And it's a good idea to understand your data so that it's easier to convince other people of your ideas that it is useful in this real world or the system will improve with this idea. And it's also supposed to kind of improve the data quality because we understand our data. We can remove the outliers, we can remove duplicates, we can impute our data in a certain way, right? So the next step is data prep and feature engineering. Again, once we have done our EDA, the focus of this step is on data cleaning. So visualize data. If the data doesn't have enough label, we annotate the data. If we have human in the loop kind of system or active learning kind of system, we can add additional unlabeled data and then we can annotate those data points where the model will benefit the most. And then cleaning the data by removing outliers or low quality examples, right? So this is all about focusing on data cleaning or improving the quality of labels by having the most valuable samples in our annotation set. Then we can have iterative transformations so that we can do feature engineering. We can do deduplication of samples. A lot of aggregation can happen in terms of if you're building a feature engineering pipeline, what can happen is each feature could be an aggregation step and it could be an expensive step as well, right? So we could have like multiple joins for multiple features. Now, another part of this is that making the features visible and shareable across data teams. And there are a lot of open source tools which allows us to do this. The next step is develop and train. We are kind of merging these two steps in this cycle, develop and retrain. And here we are kind of considering the space of models we want to explore, and hyperparameter optimization. AutoML is something which is quick and easy as first step to get a quick baseline, and we can later on improve on that with our understanding of machine learning and data. So this is our develop and train step. The next step is review and deploy, right? So periodically, maybe twice a month or something like that, uh, all the developments in experimentation is reviewed by a senior leader. And if an idea passes the review process, we plan to ship it to production. And this step also kind of involves other things like tracking the model versions or managing model artifacts and what are transition when we have improved a model. So what is the change in state of previous model to the next state, right? So all these tracking of artifacts, all these things come in this review and deploy. And of course, there's a deployment step. The next step is model inference and serving. So again, once we have built our model and we have deployed it, we want that the model is accessible to the application which will consume it or the users either through APIs, right? And there are other things which can happen in this step where we have to make some choices. For example, what is the frequency of model refresh? What should be the inference time? If the inference time is too high, do we need GPUs for machine hardware, right? Hardware requirements and other production specifications, which helps us give the users a better experience. The next step is model monitoring. So we kind of track the data distribution shifts with respect to the model. And there are some statistical methods we can use so that we can understand if the data distribution is shifting. Then there are these guardrail alerts. So we kind of keep track of certain metrics for the model. And if the metrics deviate too much, then we have a guardrail alert. We should also think about monitoring in terms of if there are large scale attacks, how do we clean the data? Or if we have some kind of adversarial attack, how to make our models more robust. But at the least, we have to monitor these things. And then this cycle kind of continues and we loop, right? So a high level idea is that we have some data which we have collected through various means or annotation, or the application is giving it to us. Once we have the data, we build a model out of it, and that model goes into the monitoring process which the users are also experiencing simultaneously, and that user experience and interaction gives us more data, and this new data can be further used to improve the model. We will look at all these things in much more detail, but this is a high level idea, this diagram of cycle between data and model. Now this is something which I'm calling a closing the loop system. So we start from here, we clean our data. So basically, we have some data which we have collected. We clean it, we prep it, we do feature engineering. There might be some system which is selecting a subset of data, either via active learning or randomly, and finding good candidates, which can be sent to annotators in this annotation step, right? Or if the model is confused at certain data points, we can send those to get some annotation. Once we have done our data cleaning, data prep, feature engineering, and so on, we are in this experimentation loop of improving the model, choosing hyperparameters, trying different class of models, and so on. And once we have kind of a good enough model, we do an offline evaluation using our offline evaluation metrics. Again, this is very application specific, so there's no point of thinking about exactly which metrics. Once we have done our offline evaluation, we are doing this testing. And this testing is very similar to what people do it in software engineering. But in software engineering, the testing are much more stricter. But we are taking inspiration from there and creating a test for machine learning. So here we are kind of having these three kinds of testing: integration testing, regression testing, and directionality testing. We'll talk more about this testing in the next slide. But think of it as real world testing and some kind of behavioral testing. There's some papers out there which talks a lot about behavioral testing. And once all these tests are passed, we have an approval process. And if the results are good, the model or the idea is approved, we go for the deployment. We deploy that new model, we call it a treatment variant. And that treatment variant of the model is exposed to a very small percentage of users. And while the users are interacting with this new model, we collect that data, we do an online evaluation in terms of what are the change in business metrics with this new model on a small subset of users, right? And once that is also good enough, again, we have an approval process. And once everyone is happy about online metrics as well on this small population, we kind of move this treatment variant to a control variant. Control variant is something where almost all of the users are experiencing this model. Like 95% of users are experiencing this model, and 5% is always kept for some experimentation traffic, right? Now, because of all this evaluation and users interaction with our model, we collect all these data. So we are collecting even the treatment variant, we are collecting this control variant, everything we are collecting, right? And we can have also some additional data from our annotation step as well. So we kind of collect all this data and this cycle continues and it goes to data clean, prep, and select data. So this is what I'm saying, that it's a closed loop system. Now the question arises that can we think of another example where annotation is not there? So let's say I have a bot detection system, and it can happen that I train the model every week. I take last week's or data or last month's data, and I train a model on that, right? And while doing that, the labels are kind of coming from some other automated way, maybe clicks or purchases or something like that. But the thing is, there we cannot really have an annotation step, and maybe in that application it's not that useful. But if I take another example of a deep learning model where images are inputs, maybe we kind of find the most confused examples, or even in the earlier data set, if the model thinks another model which is deciding whether the labels are good or not for every sample, if that model decides that okay, we should review these labels, that also goes into annotation. uh, Active learning system can give us some samples so that the model improves in uncertain areas. So there are many ways in which we get some samples which we have to annotate, and this kind of closes this loop, right? So this is what I'm calling a closed loop system. Now, we had earlier this testing, right? Integration, regression, and directionality testing. Let's talk a bit about that. That's new here. So in traditional software development, we always followed test-driven development, right? Not always, but it's a very popular practice. And what is it, right? It's just a set of sanity checks. And in machine learning, how do we develop tests, right? It's not that easy, because if it was that easy to hand code it, we would have not needed machine learning, right? So in machine learning, we use data as tests. So these three tests are basically three different data sets, or each test could also have multiple data sets. That's fine. So what is an integration test, right? So first thing is all these three testing happens on real world examples, which is coming from user or application or some real world data, right? It could be the user annotated data on real world examples, which the model should definitely get right. And the goal is that we are testing basic functionality, which means that the examples here should not be very difficult. And but it should also be the need that these examples the model should be able to handle. Maybe on this test, reasonably high accuracy or high performance is expected. Now the next one is regression testing. Testing is more about collecting some difficult example or edge case examples, or we have a collection where version 2 fixed some of the difficult examples, and in version 3 as well, that example should continue to be fixed, right? So that is the regression testing, that we are not regressing too much from the previous model in terms of we are not degrading, right? We had a collection of examples which version 1 was classifying, let's say, incorrectly, but version 2 fixed it. We want those examples to still be fixed in version 3, right? And the third one is directionality testing. This is more about testing the robustness. And it's more about if I add some noise to the input or some variation in the inputs, the label should not change. Or if I replace a word with its synonym, or if I introduce some typos, or if I change the URL or change the name of a person, those things should not change the prediction of my model, right? Or if I say that I'm happy, or if I say I'm super happy. So the directionality test is saying that if the words I'm using is more positive, so the probability of positive sentiment, if we are doing sentiment analysis, should also be more positive. So this kind of tests the robustness and directionality of our probabilities. So this is kind of all these three tests which we discussed in this loop, right? And then also about workflow tools, right? So the idea is that most of this loop is automated, and there are a couple of approval processes. So why use a workflow tool, right? First thing is standardization in terms of if we have a single piece of code and only model is changing or something, or only data is changing and so on, right? Uh, in, if that is fixed, right? If the code is fixed, then there's some kind of standardization and we have some kind of fair comparison between models. Another thing is when we build code, we have all these random codes here and there. So there are many files. Let's say there are like, let's say 30 Python files in your folder, but you need only 6 of them. And you have to run those 6 of them with certain data in order. And while doing those things, bugs can be introduced. We could have chosen the wrong code and so on. So using a workflow actually helps us because the code is standardized. Scalability is another good thing about workflow tools. For example, if I wanted to train a model on cloud or with GPU machine or CPU machine or on Kubernetes cluster, so those things are possible with a single line of code. We can choose where it will run. So it's very easy to scale without changing the code. Another thing is when we run all these steps for different versions, right? There are certain steps which has completed successfully. For example, cleaning and prep data. What if cleaning and prep data takes 2 days of computation, right? So every time we have a new idea, we don't want to compute this data again and again. So workflow tools also allow us to reuse the steps which have been completed successfully. And it also helps us to debug because we know that till this step, everything worked. And some failure happened at this step. So we can focus on that step and it kind of makes our life simpler in terms of debugging. And we don't need to start from scratch. For example, if I took 2 days or a week to prep data, I don't want to really start again and wait for another week, right? So There's no need to start from scratch. Everything is standardized, lower bugs, scalable, reusing already executed steps. These are really good properties of workflow tools. And these workflow tools, we also look at it in our course, which we are offering. And so this is finally our big picture of closing the loop. And that's all about our presentation. Thank you for joining the Curious Curator session on closing the loop in on ML systems. And just as a reminder, we are offering a 12-month data science and machine learning course. Please visit our website and look at the tentative course plan and course structure. And please enroll if you really want to.